Yeah, yeah.
Very, very straightforward.
Oh yeah. Okay, everyone.
Oh, I remember I was going to ask you, how was it having Dr. Omar?
Oh, Dr. Omar, that was so awesome. Actually, it
Yeah.
was like we had a like a mix up. I think with time zone and everything, and we Dr. Omar, he wasn't able to join us, but
Oh,
also yeah, he sent us. I think two people, Peter and Ronet, if you know, is I
I
think
don't
they're in
know
the
about
same team
them.
with Dr. Omar. Yeah, but of course, Dr. Omar promised us that next time he is gonna be there. I mean, we had some confusion with time zones and everything, so yeah. But
Yeah,
the session was great. I mean, we learned a lot of things from those guys.
he's a legend, man. He
Yeah,
is so smart.
yeah, so smart, so
Yeah, I
smart.
really like him.
Yeah.
Yeah.
Okay. Everyone, thank you for joining us today, and we really appreciate everybody taking their time to join us today for some SolidWorks tips and tricks. And I think this is something that it resonates for every SolidWorks users. I mean, we always need to update I can say our workflow so that we can increase our speed modeling. And I know with Too Tall Toby, he has done ton of videos, thousands of videos on his YouTube channel. And I think with his experience, he can share a lot of tips and tricks today. And I think everybody will have something, will walk out with something new that they can learn from this uh, session. So, yeah, Toby, welcome so much to our Tanzania Sodec user group. But we have also people from other areas, like I know from Uganda, Kenya. They're also joining us today. It's not just from Tanzania. So I think today's session is going to be so much fun.
Nice. And Matthew Dwyer in the chat says, I'm from Houston. What's up, my man? Good to see you in here.
Oh,
That's
yeah.
awesome.
Yeah, of course, we have like four user groups that they are like collaborating with us. We have one
Oh,
from
cool.
Houston, from North Tunisia, we have one from Uganda, and also Seattle area with Eric.
Nice.
Yeah, so
Wow.
expected to see some of the familiar faces.
With Eric, you said Eric Beatty.
Yeah, Eric Ibed. I think he's a user group
Yeah.
leader for the Seattle
Yeah.
Sonic
Nice.
user group.
Yeah. Another legend. You get all the legends in your user group, Edward. Good job.
Yeah. We keep pushing.
Yeah, it's good, man. It's awesome.
So yeah,
Cool.
Toby,
Well,
welcome so
thank
much.
you. Thank you. Thanks for having me. Great to like talk to you online. And it's been cool seeing the Tanzania users doing the cadpractice.com. Have you guys been enjoying that?
Oh yeah. Of course, they've been enjoying it a lot, and as you can see, we are like having like top 10. I think two users on the like top 10 of the leaderboard,
Yeah.
and I think we will give them a shout out. Those two users, I
All
really
right. Let
encourage
me
them
let me
to
see if I
attend
can
this
screen
session.
share and we'll bring it up. We'll see if we can show them.
Yeah,
There you go.
sure.
So let's see. So we got the leaderboard here and look at this.
Yeah,
KIAI, nice, and Mobo. Let's go. Number 8 and number 9. That is awesome.
that's so awesome, and expecting to
Yeah.
see them then in the number one and number two soon.
Yeah, and they just started. Like you guys just got into the system like 2 weeks ago, maybe 1 week ago.
Yeah,
So
yeah. It's so
it's
so awesome.
it's cool too. The leaderboard like updates in real time. So I mentioned to you the one day on LinkedIn, I had this up on my second screen, and then I saw Mobo was in like 80th place, and then he just ranked up like and he jumped up to like 65, and it happened like in real like I saw him move up the leaderboard. It was really cool. Like
Yeah,
it just
that's
refreshed and he moved up. I was like, what? That's so cool.
yeah, that's so awesome. That's so awesome. Of course, we had this conversation even in our user group meeting. As you remember, the photo that I sent you earlier on, that of course a lot of our users they really love your content, they really love your work, they really love what
Nice.
you put out there every week, the consistency and
Nice.
everything. And we just learn a lot of things just for free on YouTube, and that's been so
Oh,
amazing.
that's awesome. That is so awesome.
That's so awesome.
Cool. Well, thank you guys. Yeah, thanks for using it and testing it out. If anybody's watching who's not familiar, we have a platform that we developed that follows this kind of gamification methodology, which is giving users, especially giving students, these challenges, and kind of not only challenging them to go through and do these challenges, but actually tagging the challenges with some competencies. So like this first challenge here, the drill bushing, if you're a SolidWorks user, you could probably think of a workflow. You would like draw 2 circles here and then extrude it. And so for that one, you would get 5 points. But if we go a little bit deeper into the library, like if we go to level 5 here, level 6 or level 7, you'll see that the challenges have multiple competencies that you need to do. So like if you were going to do this soap dish base here, you'd have to know how to extrude, how to work with multi-body, how to do patterns, how to do ribs, how to do the slot tool, how to do thin walls. And this is also a part that's 3D print ready. So because of that, when you finish a challenge like this, you get more points for doing one single challenge, and those skills go into a competency matrix here, which is really cool. Like if you're, if you and your user group or you and your students, it's really like, it's ideal for students and educators, but it's like perfectly applicable to user groups as well. And so you can kind of gradually build out your skills and earn achievements. And that's what we're seeing here on this leaderboard. We're seeing the Tanzania crew coming through and finishing all these challenges and just rocking through and getting all these different achievements. So cool to see. And if you're out there and you ever want to give it a try, it's totally free to sign up. It's called cabpractice.com. That's the website, cabpractice.com. And it's the gamification of 3D CAD. It's very similar to tootalltoby.com, but the difference is that this one is more designed for educators. It has all in the United States, we have these privacy things called COPA and FERPA that are designed to protect the privacy of students. It's kind of like GDRP in Europe. So it's data privacy protection things that are specifically for students. And Too Tall Toby is more of a like community, like get people together, introduce people to each other, go on Discord, talk to each other, stuff like that. Well, with education and with students, we have to cut that off. We have to guard against that. We have to maintain student privacy. So that's why you'll see, like, when you look at the leaderboard, you don't see the actual usernames. The usernames are obfuscated because we don't want anybody to know who these users actually are. So that's really like the big difference. Too Tall Toby's like the global CAD community, and cabpractice.com is more like for educators with student data privacy built in. But one of the cooler things about cabpractice.com is that you can organize by my class. So like the Tanzania users group could filter their leaderboards, and then they could just see people that are in their class, in that user group, and they can kind of like see who's at the top of the leaderboard just for within that user group. So it's kind of cool that you can filter that instead of showing the whole global leaderboard, just show the class. Maybe we'll do some of these, if anybody in the user group has one that's kind of stumping them, or if you want to see me go through any of these, like maybe at the end we can, after we show some of the general tips and tricks that I've got prepared, maybe we could go through and actually like do some of these challenges and kind of see, we'll see what the crowd has to say, see what they think.
Yeah, that would be so awesome.
Cool. All right. Well, is it time to get into it? Should we get into the presentation?
Yes, we are so excited for that, Toby.
All right, great. Well, thank you all so much for having me. And today's Friday, August 21st, Tanzania SolidWorks users group. Let's go. And if anybody has any questions, let's go. If anybody has any questions, just let me know in the chat. I'll keep an eye on the chat so that I can, answer any questions you have if they come in. I'm happy to answer any questions you have, even if they're a little off topic. We don't have to stick to the topic at hand, but it's good to at least kind of have like a foundational topic. So this is one of the first challenges that we created at tootalltoby.com, and I'm going to go through and do some of the examples of how you can save time in SolidWorks and practice workflows using this challenge. So if you're watching and you want to use like print screen or the screen capture tool on your computer, you could grab a copy of this blueprint, and then as we're going through and demonstrating some of the time-saving tips and tricks in SolidWorks, maybe you could reference this drawing. So I'm actually going to do that as well, just to follow along with everybody. So I'm going to grab a screen capture here. You can use like, Windows snipping tool, or I'm using Snagit here, or, whatever you want to use to grab a screen capture. And that way, when we go through and we do the actual tips and tricks, you'll be able to kind of like follow along with some of these tips and tricks. So the presentation today is going to be Toby's Tips and Tricks 2026. It's about 45 minutes usually. We might go a little faster, but of course, we're going to leave some time at the end to answer any questions as well. And that should bring us right up to the top of the hour. Edward and I did work together and make sure we had a little bit of extra room here. So if we need to go overtime, that's fine. We can go overtime. We're happy to answer any questions that come in. I saw some of the chat earlier. I saw Grevin said, this is going to be crazy fun. Got that feeling. Yes, let's go. And Saleto is here, says good evening. And Abdul is here. What's up? What's up? And Dixon is here. Good evening, team. Let's go. And Jervis is here. Hello, hello. Great to see everybody here. Welcome, welcome. So the goals of this presentation is that by the end, if you're taking some good notes, you will have learned 3 new time-saving tips and tricks. Hopefully, we will answer some of your questions as well. And of course, we're going to have some fun along the way. So my background, just real quick here, I started doing tech support in 2001. I did over 10,000 tech support cases for SolidWorks, got a bunch of certifications along the way, and then started Too Tall Toby in 2022. So if you have any questions about anything, like I said, it doesn't have to be on the current topic. If you want to deviate a little bit, I'm happy to answer any questions you have. And we do also have some training classes you can take. So if you ever are interested in getting certified as a SolidWorks certified professional, we have a class you can take on that as well. tootalltoby.com/training. We actually have a bunch of classes. We have a totally free class for beginners. We have a SolidWorks 101. We have sheet metal class. So we got a bunch of classes in there. Check it out, tootalltoby.com/training. All right, so we've broken this up into 3 parts. We're going to do sketching, we're going to do some stuff with features, and then we're going to go back to sketching. There's even more sketching in here. So sketching is really where everything starts, and I think it's where users can save a lot of time if they just kind of practice and remember some of the key sketching shortcuts. So as we go through here and we talk about sketching, again, practice, 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 and let me know if you have any questions. So for this model here, you know, when it comes to looking at a part, whether it's a part in the real world or whether it's a part in like digital format or drawing format, you always ask the same questions. You always ask yourself, where should the origin be located and what should my starting sketch look like? So it's just something that, you know, me as a user, I just kind of have that workflow built in. Where should the origin be? And then the second one is, what should the first sketch look like? You know, and that's also going to be like, what sketch plane is it going to be on? You know, how is it going to be extruded? Things like that. But these are always questions. Every time you start any model, before you even start sketching, before you even get into 3D CAD, you should be thinking about this. Like if you look at parts in the real world, you should be thinking about this as well. You know, where should the origin be? What should the first sketch look like? So I think that for this part here, the first sketch is going to look like this. It's going to kind of have this shape here. And I think the origin is going to be down here in the corner. Now, why you choose the location of the origin, it kind of changes from model to model. But in this case, it's because I've got these kind of envelope dimensions that are originating from that corner. And there's some other dimensions on this print that also are related kind of to that area, like the max width here. You know, this model's got centerline symmetry. I think I'm going to put the origin right here, right at the middle. And so I'm going to be able to extrude using that max width. So you always want to ask yourself these questions. Where should the origin be? What should my first sketch look like? But then when you get into the actual sketching, there's a lot of stuff you can do to save time. Even when you're just beginning that first sketch, like when you go to start a sketch in Essentials, we always teach the users, select a plane, begin a sketch, orient your view. Select a plane, begin a sketch, orient your view. It's like this mantra that we say to students when they're taking Essentials. Select a plane, begin a sketch, orient your view. And it's something I still say to myself, like when I'm going through and doing 3D CAD, it's like select a plane, begin a sketch, orient your view. But even in this mantra, there's a lot of moves, a lot of places where I see people kind of wasting time. Like in SolidWorks, in the tutorials, in the built-in tutorials, what they tell you is to click extrude first and then click on the plane. But the problem is that doesn't always work. It depends on what mode you're in. It depends on if you're in an assembly, if you're editing a part in assembly versus not editing a part in an assembly. There's some situations where you're not going to be able to click the feature command first. You know, and if you go into the tutorials, if you go in here to like the help tutorials, it tells you in the tutorials, like click extrude, and then this shows up, and then click on your plane, and then you can start sketching. But I don't really like that workflow because it's inconsistent. It's like dependent on what mode you're in. So instead, what I like to do is select a plane, begin a sketch, and then orient my view. Now, this workflow, select a plane, begin a sketch, orient your view, has some nice shortcuts built into it as well. So let's say, for example, I show these planes here so you can see my front, top, and right plane. So when I go to the front plane and I go to begin a sketch, I don't, first of all, I usually try not to click on the words. Instead, I try to click over here. Now, this might seem like a little thing, but the reason that's significant is because if you click on the words and then you click on them again, it puts you into this rename, right? If you ever had that happen, just put a number 1 in the chat. If you've ever had that happen where you're like trying to edit a feature or click on a feature or something, and then it goes into a rename unexpectedly, or it's like really not what you're trying to do. So there's this guy who used to work at SolidWorks. His name was Joe Galliera. Everybody called him Flow Joe. And he's the one who told me this. He said, if you click on the name and then you take a deep breath and then you click on it again, that's kind of the Windows shortcut for rename. But if you click on the icon, you click over here on the icon, and then you take a deep breath and then you click on it again, it does not take you into a rename. So it's a little subtle thing, but if you just kind of get in the habit of like clicking here instead, then you'll never have that situation happen where you accidentally go into a rename. So we'll click over here on this icon, and then we see that we can go up to the command sketch and then choose the sketch command, but that seems like a lot of work. Like, what if sketch isn't currently available? Well, instead, as soon as you click on that, you get this menu here called the context menu. Now, this shows up if you left click or if you right click. And in the context menu here, you've got the sketch command. The context menu is super valuable because you can also right mouse button and choose customize. And so that means that there's going to be some situations, like for me, it's like mirror sketch, where when you learn that this is a thing, you can save so much time because you can actually right click and customize, but we'll get to that in just a little bit. For now, what I want you to know is that when you either left click or right click on that sketch plane, you can begin a sketch. And then the very first sketch that you get into, the orientation is going to change automatically. So when you select a plane, begin a sketch, the view orients automatically. For subsequent sketches, if you want, you can have that happen automatically by going in here to sketch and then choosing this option here, auto rotate view, the very first option. So then every time you start a new sketch, the view will be oriented. Now, personally, I actually don't really like this. I don't use it that much. So like my first sketch, I'll begin a sketch and then I'll go in here and I'll like extrude this geometry, and then it takes you back to the original view. And then you go to your next sketch here. Like when I go to begin a sketch here, I kind of want to decide myself if it's gonna rotate. So when I click to begin a sketch here, you can see that it automatically rotated, but a lot of times that's not what I want. A lot of times what I want is I want it to manually decide if it's going to rotate. It's kind of like disorienting for me. And I do so much surface modeling that I'm used to working on kind of odd angles. So I want it to be a little bit more intentional. So I usually go in here and I say sketch, don't auto rotate the view, but that's up to you. It's up to each user. Each user is going to get a chance to decide that. Let me change my view transitions were set to off. So that's why it was jumping. So what I do instead is I pick this face here. Now you'll notice the same workflow is available. You pick a face and then right here, begin a sketch. So I'll pick this face and I'll begin a sketch, and then I'll orient my view by holding Control and pressing the number 8. So Control 8 is how you can orient your view when you're trying to kind of quickly change to what's called a normal to view. Control 8. So if I bring up my keyboard here so you guys can see this, just make this a little bit bigger when I want to show the keyboard. So I'll start a new sketch, or maybe I'm in a sketch and I rotate the view, and then you hold the control button, you press the number 8, and that gets you normal too. Now this might seem like it's like very fundamental, but there's just so many users that I see spending so much extra time, like clicking the plane and then going up to the toolbar, clicking there, or other workflows. This is just such an important workflow. So you never have to go up to that toolbar. You just pick a plane and then choose a sketch command from the context menu right here from the menu. Also, remember, you can click on that icon instead of clicking on the text. So click on the icon, and then to orient your view, what you can use is you can use Control and the number 8. And the thing is, this kind of ties into another good shortcut to know, which is that Control 1, 2, 3, 4, 5, 6, 7 are all of your standard views. So when we're working here in SolidWorks, if we click in the background and press Control 7, that's isometric. Control 1 is your front view, 2 is your back view, 3, 4, 5, 6, 7. This is hotkey to all of those. And then if you click on a face, you can also do Control 8, and that gets you normal too. So again, just kind of helping users save time. You don't have to like go to the cube, or like a lot of times I see people, they'll press the space bar, they'll go to the cube, and then that's how they'll change. Or, there's a lot of ways you can change your views, but I think the fastest one is just the one that's already right there waiting for you. Control 1, 2, 3, 4, 5, 6, 7 to get through your standard views. And then finally, you can see here that when it comes to beginning that first sketch or beginning any sketch, if you want, you can turn this option on to auto rotate the view. Again, me personally, I prefer to use Control 8 or N. So N is a shortcut in Onshape. Like I use a lot of different CAD systems, and one of the ones I use a lot is Onshape. So when I begin a sketch, what I like to do is begin a sketch, and then I'll press the letter N, and that gets me normal too. But wait a second, a moment ago, I showed you that Control and the number 8 gets you normal too. So Control 8 gets you normal too. Or if I press the letter N, it gets you normal too. Well, when you right click here and you go into customize, you can go into keyboard, and then I can search here. I'll search for normal. And then you'll notice here that you can actually assign more than one keyboard shortcut to the same command. So this is kind of helpful too. Like if you're used to one, but you're experimenting with a new one, you can kind of like get in there and add in some new functionality there into your keyboard shortcuts. So Control 8 and N, they both do the same thing. They both rotate normal too for me. And the reason why is because N, I'm already used to using N in Onshape, and I just want to make that workflow consistent across both CAD systems. So that is a little bit of time-saving tips and tricks when it comes to beginning a sketch. And so in the case of this model here, I would probably go to the front plane, begin a sketch, orient my view, and get myself ready to create this geometry here. Now, when it comes to creating this geometry here, another thing that's going to really save you a lot of time is learning how to leverage the S key. So I consider the S key like an ultra power move in sketch mode. I made multiple videos on the S key, on how much time you can save with the S key. You can watch those videos on our YouTube channel, the S key in SolidWorks, the ultimate shortcut. But basically the idea behind the S key is that anytime you're working in SolidWorks, you can press the letter S and a menu will show up. So I'm here, I'm working in SolidWorks, I press the letter S and a menu shows up. The cool thing is that right now I'm in sketch mode. So the menu that shows up has a bunch of sketching tools on it. So here I can press the letter S, and then this menu shows up here. So it's got the sketching tools. Now I can press the letter S, and now I can jump to a different sketching tool, like the dimension command here. And I can add in dimensions here for this thing. And then you can also customize this S key. So one of the customizations that I've done is I've added the extrude command and the cut extrude command here. So when you're in sketch mode, you can press the letter S, and then you can jump into cut extrude. And we can take these holes here, and we can say right mouse button through all. We'll cut extrude these through the whole thing here. And whoops, wrong direction. There we go. And then what we can see is when we press the S key, now the menu's different. So a moment ago, we had commands like sketch circle and sketch dimension. You saw me use that sketch dimension and sketch circle command, but now those commands are gone. Why are those commands gone? Well, the reason they're gone is because in SolidWorks, you work in 4 different modes. You work in sketch mode, that's your first mode, sketch mode. You work in feature mode, you work in assembly mode, and you work in drawings mode. Well, each of these 4 modes has its own S key menu, and that's what makes it really powerful, because now I'm out here at the feature level, and I could choose the fillet command and say I want to make a 15 millimeter fillet here. So we'll make a 15 millimeter fillet here. And then I could pick this corner here and say I want that to be applied to, pick this corner here, apply that to all 4 corners, and then we're done with that. Or I could press the S key and jump into the shell command, and I could shell this thing out. So we'll make this like 2 millimeters, shell this thing out. So the S key is so powerful because it saves you having to always move back up here to these menus, and you kind of start to develop some muscle memory. Like there's only, there's probably like 12 commands that you could use in sketch mode to get really far in SolidWorks. There's probably a lot of commands that you could learn in feature mode that get you really far, fillet, shell, delete face, move face. Like these are the commands that are really going to get you far. And then also if you're doing a certain type of work, like if you're doing a lot of sheet metal, let's say, and shout out to young Dale, says it's a pleasure to have you here. Thank you, my friend. Glad to have you here as well. And so you can see here, if I go to like front plane, begin a sketch, and then I go to sketch a rectangle like so, and then I'll take this bottom line here and make it for construction. Now I could S key and jump into a sheet metal command. So why is this command here? It's because I right clicked on this S key menu and I said customize, And then I added the sheet metal command to that. So like whatever type of a work that you're doing this week or this month, you could add commands that are related to that type of work to save you on your workflows. So like I could pick this edge here and then S key and jump right into the sheet metal flange command, or I could get into this geometry here and then create an additional tab that's sticking off here and then just turn that into a tab right from the S key menu. So being able to navigate through those commands really quickly by just having one single toolbar is like so powerful. One single shortcut is all you really need to know. So what this slide here is illustrating is what I do to the S key when I go from the out of the box to the Toby version. So what I do is I get rid of the line flyout menu, and then I replace that with line, rectangle, center point, rectangle, and construction line. And then I also add the boss extrude and the cut extrude. If you just do these two changes to your regular sketching S key, you're going to be miles ahead of the game. It's definitely a super, super helpful shortcut. See here, Aiko is here, says good evening from Uganda. What's up? Welcome, welcome. And Amina is here, says good evening, guys. Good evening. Welcome. Thanks for joining us. So the other that's number one. You know, that's like the number one shortcut to save you time in sketch mode. The number two shortcut to save you time in sketch mode is just to really practice and refine your auto dimensioning game. You got to have your auto dimensioning game enabled, and you got to have it down. You got to practice to get this down. So to turn on auto dimensioning, what you do is you go in here to your system settings, and then you go into sketch, and then you say enable on-screen numeric input and create dimensions only when a value is entered. So if we go in here to SolidWorks and then we go to options, sketch, it's this option down here, enable on-screen numeric input, and then create a dimension only when a value is entered. If you make sure that you've got both of those enabled, you check both of those on, enable on-screen numeric input and create a dimension only when a value is entered. If you enable both of those, then the next time you go into sketch, what you'll see is that when you press the letter, you know, in this case, I'm just going to press the letter S on my keyboard again. So I come in here, I press the letter S. Let's say I go into the line command. I begin a line starting here. I move my mouse down. Now what happens is I can let go of my mouse. So I don't click again. I just click one time. The only time I clicked was here. So left click here, left click one time. Okay, it's not click and drag, just left click one time. And then I move my mouse down here, and then I can type in 42, enter, move over this way. I can type in 69, enter, move up this way. Now this time I'm not going to type anything, and then I'm going to come back here, and this time I'm not going to type anything either. Because if I typed in 42 again, it would go over defined. If I typed in 69 again, it would go over defined. So that's what this second option down here does. Create a dimension only when a value is entered. Only when a value is entered. That means you don't get auto dimensions for every single entity you create. You only get an auto dimension when you actually type something in. Now, in order to get really good at auto dimensioning, you kind of have to learn the game a little bit. So like with lines, single left click, move, let go of your mouse, 130, enter, move down, let go of your mouse, 75, enter, et cetera, et cetera. When it comes to circles, S key, circle, single left click, move your mouse, let go of your mouse, type in the diameter, enter, single left click, move your mouse, type in the diameter, enter. When it comes to rectangles, so S key, rectangle, single left click, move your mouse, let go of your mouse, type in your height, enter, width, enter. So you get to type in both there, single left click, move whichever direction you're going to go, height, enter, width, enter. So you have to practice this a little bit to get used to it, but once you do, it's like it's game over. Like you just save so much time when you really learn how to hone in that auto dimensioning game. And so to practice with this kind of stuff, first of all, take a look at those videos. We have videos on those as well in the Too Tall Toby YouTube library. But to practice with this stuff, you just want to get a drawing, like that drawing that I showed earlier, and then just go through and start practicing. So for example, if I was to show this drawing here, and I was going to practice doing some auto dimensioning. So if I was going to like come over here this way, come up, come over this way, come up, come over, come down. Well, what I could do here is I could go into SolidWorks and I could go new, and this is going to be a part in millimeters, front plane, begin a sketch, S key, line, single click, move your mouse, let go of your mouse. This is going to be 135, enter. Move your mouse up in this direction, let go of your mouse, 12, enter. Move your mouse back this way. Now, this dimension is a little bit strange because it's actually 135 minus 25, because I'm trying to create the auto dimension in this direction here. So 135 minus 25. Well, we can actually do that in the auto dimension command. So here, if I go in that, that next line there, if I go 135 minus 25, enter, it gives us that auto dimension. If I go this way, which is going to be 65 minus 12, enter, it gives us that auto dimension. And then I can come over here and down. This one's going to be on an angle. But the thing is, this is not what the design intent was from the customer. Well, check this out. In SolidWorks, you can grab a dimension grip and you can relocate it. So I could grab this dimension grip here and relocate it over to here. And now I'm getting that 25 that the customer asked for. I could take this dimension grip here and drag it down to the bottom. And now I'm getting that 65 that the customer asked for. So, how do I know this? How do I know that this is a thing? Well, I just know it because I like practice, and I experiment. And I'm like, oh, I wonder what would happen if I did this. I wonder what would happen if I did this. Like, that's how you learn these little nuances. You just have to like have that curious engineering mind. And you just have to say like, well, I wonder what would happen. What would happen if I clicked on this grip and dragged it up to here? Will it go over defined? Oh, it does go over defined. Oh, wow. I didn't realize that was going to happen. Oh, why is this text down here red? What would happen if I clicked on this text that's red? Oh, it actually starts a new command over here, the sketch expert, and it helps me try to diagnose what's going on with my sketch. Well, what happens if I click diagnose? Oh, it shows me some different potential solutions. Like if I get rid of horizontal, it won't be overdefined. If I get rid of this distance dimension, it won't be overdefined. If I get rid of this distance dimension, it won't be overdefined. I'm going to get rid of that one, except, all right, cool. Now my sketch isn't overdefined. I never knew that before. You just start clicking around, clicking on stuff, and just like, kind of investing in yourself a little bit and just spending some time, and you can really start to learn some of these nuances. So that's how you could auto dimension the first part of that first sketch, and then we'll show you the second part of that sketch in just a moment. The third thing that happens in sketch mode that I think is such a huge time saver is just learning and refining the line arc line workflow. And this works in coordination with the auto dimensioning tool. So the line arc line workflow is when you're in SolidWorks, if you do have some arc geometry, like let's say at this end here, it's not a straight flat spot, but instead it's an arc. So I'll get rid of this geometry here. So I'll just get rid of all of it. So we'll go S key, bring this up here. So we'll go S key, line, single click, move our mouse, let go of our mouse, 135, enter. Now, without clicking anything, we can take our mouse and just put our mouse over this end point and come off of it, and it gives us an arc. Now, you can actually get up to 8 different solutions from this. So you can go tangent positive, tangent negative. You can do reverse tangent positive, reverse tangent negative, or you can do perpendicular tangent positive or perpendicular tangent negative. Now, the way that you do this is you put your mouse over this end point. And once you put your mouse over that end point, you can see here that you can move your mouse in one of these 4 directions. So you can move your mouse off in one of these 4 directions, and that's going to define what type of tangency you get. So you put your mouse over this endpoint, and that defines it. Now, does anybody know what the shortcut is for this, the letter shortcut? If you know what the shortcut is, type it in the chat. If you happen to know what the letter shortcut is to change from a line to an arc. So if you know what that is, type it in the chat. Let's see if anybody knows. Edward thinks Control A. You're close. Not Control A, but you're very close. Let's see here. David says A. Yeah, exactly. It's A. A is the shortcut. So when you're in the line command, you could press the letter A, and that'll switch you to an arc. Except we have a problem, because if we press the letter A here, it's typing into our auto dimension, right? We've got the ability in auto dimension to define a radius of this arc. So if we type the letter A, now we're stuck, right? Well, when you have auto dimension turned on, what you can do is right click, and then in the right click menu in the background, you can switch to line. So switch to line here, or you could right click and you could do switch to arc. Arc has a shortcut you can get to. So if you're in the line command, you can't press A, because A is the auto dimension for that line dimensions. That doesn't work. But what you could do is you could come down here and touch the end point and then come off of it. But a lot of times you do that by accident. you're trying to do something else, and then you're like, oh, now I'm in the arc command. No, I got to cancel out. Well, you can just right click and say switch to line, and that'll get you back in there. So I don't know if Control A actually does it or not, Edward. After I said that, I wasn't sure. So let me just try Control A. Does that do it? Nah, it doesn't do it. Let's see. Get back to line, Control A. Nah, I wish. That would be cool. That would have taught me something. Maybe you could change it in the shortcuts. I don't know. I'd have to try. It doesn't come up enough for me to like, even though I like shortcuts, I don't try to put in too many. I just try to find the ones that are like the lowest hanging fruit. And that helps me, helps me. So this one, like if I ever happen to end up in an arc, I'm comfortable just doing right click, switch to line. Right click has so much power, underused power in it. And we're going to talk about that a little more when we get to the features section. So the other thing you can do with that arc is you can define the radius, which is really helpful because if you're doing like a tombstone shape, like let's say I wanted to create a tombstone shape for this part, I could single click here, move over. I could type in, or actually they move up first. So I'm going to move up here to a height of 50, and then I'm going to come back, touch the end point, come up and over. And then I'm going to say that I want a radius here of 27. Okay. And then enter. And so now I've defined the radius. Now I can keep coming around until I can inference the 180 degree from the original point, single click. Then I can come down here like this, and then I can close this off. And look at that. That's a fully defined sketch. If we had a hole in the middle of that thing, if this was like a lug, you could come in here and you could create a hole. And then you could say you want that to have a 25 millimeter diameter. And look, nice, fully defined sketch. And that's really the power. That's what you're really going for when you practice these workflows. You want to be able to, at will, create certain common engineering shapes that are fully defined, parametrically sound right from the start. So we can come over here. We could say that this has got a radius of 27. We'll enter that radius first, 27, and then we'll come down here to the 180 degree, come down like so, close that off, S key, circle, single click, move our mouse, 25, enter, fully defined sketch. Like that's what you want to be doing when you're running your cycles and when you're practicing. Okay, and the bonus tip here is, this is pretty nuanced here, but like, when you are sketching, if you do click, 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 that's a chain of lines. If you do click and drag, that's just one line. I'm not going to spend too much time talking about this because it doesn't come up that much. But I mean, the one time, all right, I will talk about it. Actually, the one time where this does come up, where it's pretty useful, is when you're trying to create a relationship to something that's relative to a midpoint. So let's say, for example, I wanted to create a hole here that is 10 millimeters in diameter, and that is exactly vertical to the origin. Well, what I could do there is I could S key construction line, single click here, left mouse button and drag, and like hold the button down. So this is an actual drag, like I'm actually holding my left mouse button down. Then I could let go of my mouse here. And what happens is because I did a click and drag, the line properties are enabled right off the jump. So then I could make that line vertical after I drop it in place there, vertical, and now that point is vertical. That's the only time I really use that click and drag, is if like if I don't want to. Sometimes when you're like when you've got a busy sketch, you want to create a line that's vertical, but you don't want to accidentally inference another point or horizontal. So sometimes I'll make a line like this. I intentionally make it at an angle using click and drag, and then I'll let go of it and I'll come over here and make it horizontal. But honestly, those times are getting further and further apart, because I went into because in Onshape, H is the shortcut key for horizontal and V is the shortcut key for vertical. And I never really thought about adding shortcut keys to my sketch relationships until I started using Onshape, and then I was like, whoa, this is awesome. So if we go to customize, right mouse button, customize, and then you go here to keyboard, you can look up VERT, and then it's kind of down here at the bottom. Make vertical. So this is others, make vertical. So that means in a sketch, you can make an entity or 2 points vertical by pressing the letter V on your keyboard. And then there's also one for horizontal. And so I map that to H. So what that means is now when I'm in this scenario, I'll just draw the line, maybe give it a dimension, hit escape, click on the line, and then I'll press V. Now it's vertical. So that's like another, been a big step up in my game. If it's like too busy over here and I can't make it horizontal, I'll make it like that, hit escape, click on that line, and then just press H, and now it's horizontal. So that was something I didn't know for a long time or didn't think about, like adding relationships for this. There's also one Q in, again, in Onshape. Q is change from solid to construction. Well, let's do it in SolidWorks too. So SolidWorks Q. So you take these lines and change them from solid to construction just using Q. And that way you can kind of draw everything as a line and then change it back to a construction just with a single keystroke. So those keystrokes, it's not in the PowerPoint, but those have been a big change in my game too. Definitely up in my game. So we covered a lot of stuff there in sketching part 1. We talked about how to select a plane, begin a sketch, orient your view, how to use control 1, 2, 3, 4, 5, 6, 7, 8, how to click on the icon, not the name, how to use the S key, how to do auto dimensioning in sketch mode, how to do the line arc line. And the bonus tip was to click and drag versus click and move, click, move, click. There's one more tip in here that actually, I think I used to have it in the presentation, but I don't have it at the moment, which is the dimensioning angles to the dimensioning angles to an invisible line. So when you've got geometry like this, actually, let's do it like this. When you've got geometry like this and you want this line to be at a set angle, a lot of times what you'll do is you'll go in and you'll create a construction line, a vertical construction line, and then you'll be able to define this angle here. Like, let's say this angle is 25 degrees. You can go in and do it like that. But in sketch mode, you can also click the dimension command. Until you went on, you stopped being on mute. You okay? They may Edward.
Sucks.
Hello, Toby. I think you mute your mic. We can't hear you.
Oh, okay. I mute. Let's see.
Hey?
Stand by.
Yeah, we can hear you. Can hear you now.
Yeah. Yep. Okay. Interesting. I think I accidentally muted myself.
Yeah.
So for this one, you can see here, if I click on this line and then I click here at the end point of the line, you get this 4-way arrow, and then you can click on that 4-way arrow and that lets you create a dimension as well. And what's nice about this one is it works in drawings too. So if you were creating a drawing of this part here and you wanted to create this 25 dimension, you know, in the old days, or this 15 dimension, in the old days, what I would do is I would draw like a teeny tiny construction line, and then I would create the angle to that construction line. But you could actually just click on that edge and then click on the end point, and then you can do a dimension to invisible, you know, an invisible vertical reference there. So for this part here, you know, if I was going to go through and kind of start modeling up this part here, what I would do is I would start with that first sketch like we talked about. I would start with the origin being in that lower left corner, and I would attempt to model this up by choosing to create a new part, going front plane, begin a sketch, S key, line, single click, move over. Okay, we get our auto dimension there, 135, enter, move up here, 12, enter, move back this way, 135 minus 25, enter, move up this way, 65 minus 12, enter, move over this way a little bit, come all the way down here to the lower point, click on this dimension, grab this grip and move it down, click on this dimension, grab this grip and move it over. That way we're matching the customer's design intent. And then I'd finish off here by doing S key dimension from this line to this end point here, click on the end point and get that invisible reference, and we can make that 15. Or the other one that I use a lot is create a dimension to a plane. So I'll begin the dimension command. I'll click on this line here, and then I'll just come over to the tree and then click on a plane from the tree. So I'll click on the right plane here from the tree, for example. That's another one that I use a lot. I'll just dimension to a plane in the tree instead of having to create that little tiny construction element. And that gives me the geometry from that first sketch, nice and fully defined, fully constrained. And then from there, we're going to get into some of the extrude shortcuts. But I figured this would be a good time to ask if anybody has any questions. And then if anybody has any questions, I'm happy to answer them. Otherwise, we're going to move on to part 2. We're going to talk about some different stuff you can do with features. you guys are good to move on, just put a number 1 in the chat if you're good to move on. If you have any questions, feel free to ask. You can either ask in the chat or you could unmute. How do you think it's going so far, Edward?
Yeah, I think it's going pretty great. I mean, with sketches, you know, sketch is a foundation of any geometry that you're trying to model. So, and a lot of models, they build errors. A lot of errors, they originate from sketches. So I think it's pretty great to master these tips and make sure that you fully define your sketches and you make sure that everything's in check.
Yeah, well said. Yeah, completely agree. And it's you know, it's like you use sketches for everything, so you may as well learn how to navigate through them quickly. You know, you want to get this to the point of like flow. You know, you want to just be able to kind of flow through the 3D CAD, and that way you can focus more on thinking about the engineering, because like 3D CAD is not engineering, it's just a tool that helps you get to the engineering challenges. You still have to figure out, how are these parts going to fit together? How are we going to manufacture them? Is it going to hold the required load conditions? Like all those cool engineering challenges is what you're trying to get to. And if you just kind of get your sketching game down to where you don't even really have to think about it, then you can focus more on those other things.
Oh yeah.
And it looks like Davidi or David is saying another good way to hide show planes is with P. Yeah, that's good. I like that one. If you go to, so if you're here in SolidWorks, let's say we get out here and then we press P, you could maybe set that up to hide and show your standard planes. I think I'm using a slightly older version of SolidWorks here, but it's like this one here, hide show primary planes. So if we go into right mouse button, customize, then we could go here to keyboard, and then we could search for planes and see if that option is there. So let's see here. So view, and then it's got the little eyeball there, primary planes. So if we went over here and we said we wanted that to shortcut to P, and we say, okay, now we can click in the background, we can press P, and that hides and shows our primary planes. And then that also is how you do it in Onshape, actually. How you do it in Onshape too. So that's good. I like that. Kind of quickly show and hide those planes. Very nice, very nice.
I think you have a question in the chat from Gervos.
Yeah, it says, I've seen this like a feature or kind of sketch tool named Block. How useful can this be in simplifying sketching? Yeah, I don't know if that's Davidi or David says, correct. Actually, you have to set it up. It's not even. Okay, cool. Yeah, nice. I like that. Just say David. Okay, thanks. So you can see here that the other question was, I've seen this like a kind of tool, like a sketch tool named Block. So what the block command does is it lets you take a group of sketch geometry and it lets you bring that together. So it's tools, blocks, make. And so when you do tools, blocks, make, it's kind of cool because it all moves together. And when you've got multiple instances of the block, you can actually start to incorporate like motion, almost like assembly motion. So if this was like a multi-bar linkage here, I could take these 2 points and make them coincident. And then when I go to move one of these, it'll actually move with like an assembly motion. So blocks can be really useful for that function. There are other functions they can be really useful for too as well. So like this is an example of kind of taking the idea of what you're doing with an assembly and putting it together in blocks. That can be really helpful there. Another thing that's kind of cool about blocks is that they scale independently. So when I take this block here, it'll scale independently of the other blocks, but it also scales relative to itself. Like all the geometry scales together relative to itself. And then you've got the ability to take one sketch and kind of use it, like for example, for a loft, and you can kind of scale it incrementally along the length of a loft. So I find them to be very useful for that as well. And I especially find them to be useful in drawing. So when it comes to like managing geometry in a drawing or managing geometry in a title block, that's where blocks can be really useful, just as far as them being like utilitarian. So here you can see a drawing on an A-size sheet of paper. And if I was to make a change to this drawing, like let's say I get rid of this note here and this note here, let's say. And then what I'll do is I'll do like a trim command, and I'll kind of trim up this thing through here, and then we'll just get rid of all of this. So now what I can do is I can take this entire title block here. Maybe sometimes what I'll do is I'll put a point down here to act as like the reference when I go to copy and paste this. So I'll take this entire title block, and then I'll do tools, blocks, make, then I'll hit the check mark here. So now I've got this title block, and then I'll copy that, and then I'll start another drawing. You know, this would be like when I'm setting up my title blocks or setting up new title blocks for a new customer, something like that. So now when I go in here to edit sheet format, I can just blast all this away, and then I can Control V and paste the original title block, and everything kind of moves together. So it just makes it really easy for me to take that and drop it into place. So anytime I have stuff that's going on in a drawing, like a lot of times in drawings, that's when you tend to have multiple elements that need to work together, or like you've sketched out the customer logo, things like that. Block works really well because a lot of times if you just copy and paste a group of information, then the copy and paste, like the scaling doesn't adhere to the subsequent instance. Like when things aren't blocked together, when you scale, a lot of times individual components don't scale the same, like if one thing is a note and other things are lines. So yeah, I like blocks a lot. I mean, they're really helpful, and that's just like kind of scratching the surface a little bit of how they work. But now you kind of have a little bit of knowledge of how to get in there and use the blocks. They're very useful, and they have a lot of different potential applications. So yeah, I like blocks. Definitely worth learning how to use them. You don't use them all the time, you know, but when you do have the opportunity to use them, they can be super helpful. So I went a little too far. A little too far of my undo. It's all right. Grab the script here. Okay, great question. Thank you for that question. And here we'll go. I like going to the plane. Okay, let's see here. Wow. This is kind of thinking I can even sketch dance now with a block. Yeah. Awesome. Glad that helps. And David says, yeah, blocks will be helpful with CSWE as well. Yep. The CSWE is a cool exam because they kind of randomize which questions the users get from the different modules. So yeah, you could definitely end up in a situation where you need to know how to use blocks. And Abdul says, at the end, can you tell me a little bit about the CSWA exam? Sure. Yeah, no problem. We can definitely talk about that. All right. So when it comes to features, the big thing you want to know about features is how to access your end conditions a little bit more easily. So an end condition is something that is typically described when you're using an extrude command, but you do have end conditions in other commands like pattern. You'd consider a pattern having an end condition, or like a revolve can have an end condition as well. But we're going to talk today mainly about the extrude command. So with the extrude command, the most common type of end condition is blind. Now, when you get into the blind command, what you want to know is that the end condition depth is automatically highlighted. So when you go into an extrude command, if I go here, S key extrude, if the current extrude end condition, which is over here, if the current extrude end condition is blind, then what'll happen is this will be editable. Now, the thing is, in the newer versions of SolidWorks, it's kind of annoying. SolidWorks like remembers what your previous end condition was. So this is where knowing about the right-click menu becomes super powerful. So if you right-click, all your end conditions are listed here, and that means you could go into the right-click menu and you could change this to blind. And when you do change it to blind, again, what you want to realize is that when this becomes blind, this becomes highlighted. So what that means is if you begin a new extrusion, or if you begin a new extrusion and it defaults to blind, that's great because that end condition is already highlighted. But if you jump into an extrude and this isn't highlighted, that's okay. It's not the end of the world. Just right-click blind, and now you can immediately type the depth of the extrusion, 85, enter, and it finishes the command. So this is such a nice workflow because we do this so often, especially with cuts. If you go into the cut command here, if I go S key, create a circle here, I'm going to make a little pocket here, 30 millimeters diameter, S key extrude cut. I know that as soon as I jump into that command, I'm going to be in the blind end condition. I'm going to be able to type 5, enter, and just be done with it. I don't have to move my mouse over and choose things. And even if I wasn't in the blind end condition, so if I went extrude here and like it was set to through all from a previous extrude, I could always right click and choose blind. And I know that as soon as I choose blind, the end condition depth is going to be highlighted. So now I can type 2, enter, enter, and I'm able to just keep moving forward with the challenge, keep moving forward with my design. So this is where you can really save a lot of time, is just kind of understanding what happens or what is going to happen next when you access certain types of commands. So for example, this first boss extrude, it wouldn't be a blind extrude, it would be mid plane. So I'm here in sketch mode, I go S key extrude, right click, mid plane, 85, enter, enter, and I'm done. Now, like, how did I know that? How did I know that's what was going to come up? I just know because I know what the workflow is, right? I practiced the workflow and I took a minute and remembered, like, whenever you right click and go mid plane, the very next thing that happens is the depth of the extrusion is highlighted. So I know as soon as I go right click mid plane, I can immediately let go of my mouse, go over to the 10 key, 85, enter, that updates the preview, and then enter again, and that lets me move on with the design. So learning that these different end conditions exist, learning that they are in the right click menu, and learning kind of what is going to happen when I do this, this will happen next. When I right mouse button and choose blind, this will be highlighted. When I right mouse button and choose mid plane, this will be highlighted. It's such a powerful element of SolidWorks. Now, another one that you can learn that's super helpful is when you right click and you choose through all. What happens next when you choose through all? Well, what happens is your mouse, the actual mouse itself, changes. And what it changes to is a mouse that looks like this. So what that's saying is when you right mouse button, it's the same as choosing the green check mark over in the property manager. So what this means is if you pick a face, begin a sketch, S key circle, drop in a circle here, make it 30 millimeters, S key extrude cut, then what you can do is you can right click and you can choose through all. Now, what is going to happen after I left click on through all? The very next thing that's going to happen is my mouse is going to change. And what this is telling me is that if you right click, it's the same as hitting the green check mark. So what this means is anytime you have a through all cut, you can get into this workflow where you go S key, extrude cut, right click, left click, right click, and you're done. You don't have to like move up to the corner. You don't have to change the end condition, nothing like that. You're doing it all through that right click menu. And you'll find that the more and more time you spend learning that right click menu, the more powerful it becomes. Like if I go into the fillet command and I type in a radius here of 30 and I say, I want that to be filleted on this corner and this corner. Well, now if I go to right click, the little green check mark thing isn't there. Well, when I right click, I notice that here there's an OK button in the right click menu. So even if that green check mark doesn't show up anymore, you could always just right click over here and say OK, right click over here, OK. And I've used that tons and tons and tons of times to kind of speed up that workflow. So be on the lookout for those workflows, learn those workflows. And the biggest one that I can tell you about is the through all cut extrude, because we just do through all cut extrude so frequently in SolidWorks. You know, you need to put like a notch on the end of this plate here. So S key, begin a rectangle, move down here, say the notch is going to be 6 millimeters deep by 25 millimeters long. S key, extrude cut, right mouse button, through all, right mouse button. Boom, you're done. You're ready to move on to the next feature, and you've created a parametrically sound feature. Now, there's other end conditions that you can take advantage of using a similar workflow. You could begin a sketch on this face, S key, go into the circle command, drop in a circle up here, like so, S key extrude, and then you could right click in the background and choose up to surface or offset from surface. So let's say I do up to surface here, and then I click on this face here. You can see that now, what's the mouse telling me? It's telling me that if I right click, it's the same as hitting the green check mark. So what you start to learn is that it's almost like a left click, right click, like you're pressing down. I'm showing my camera here. You're pressing down with your left click, and then you're immediately pressing with the right click. So it's like a 1-2 as you kind of like come down on your mouse. So in real time, what that would look like is if I know I want this to extrude up to surface, I could S key extrude, right mouse button, up to surface, left mouse button, right mouse button. Like I kind of learned that it's the very next thing that's going to happen is going to be right mouse button equals check mark. And the more you learn about those workflows, the faster you're going to be in SolidWorks. So be on the lookout for that. There used to be some other cool things that you could do with the end conditions, but in the newer builds, they don't work anymore since SolidWorks implemented that like remember last end condition. Basically, SolidWorks 2021 or 2022, they changed this. They changed some other cool workflows that we used to be able to use, but these ones still work great. The right mouse button for end condition, reverse direction is in there as well. That's another good one to look for. Mid plane is in there as well. That's another good one to look for. Okay is in there as well. That's another really good one to look for. So left mouse button, right mouse button, left mouse button. I call it RMB, LMB, RMB. So you go left mouse button and then immediately right mouse button, and that finishes it. It's a good workflow to know about here. So like for through all, for reverse direction, anything like that, that LMB, RMB, LMB, RMB, right mouse button, left mouse button, right mouse button. Okay, some of these are no longer applicable in the new build. I'll skip over those. And then this one here, this is one that I think people often forget about. When you have a sketch that's open, you can cut through all using both directions, and it acts like a surface cut. So if I begin a new sketch here on this face, and then I go and create a sketch that looks like this. Let's see here. I'll do it like this. I'll just bring this one in a little bit. I don't want to end up with a multi-body here. So now if I go to the command S key extrude cut, and then you change your end condition, and remember, we don't have to go over here to choose it. We can do it right here from the right-click menu. Change your end condition to through all both directions. Then what happens here is you get this through all cut that rips through the entire model, and everything on this side of the arrow, there's an arrow here. Everything on this side of the arrow will be removed. The arrow indicates which side will be removed. So I'm going to click on that arrow to flip it to the other side, hit the green check mark, and then you can see here what happens. I still ended up with a body ambiguity, but that's okay. So you can see there that when you have an open sketch, you can do a through all cut in both directions. So the reason that's such a valuable workflow is because you can use it you can really use all of these in a workflow to continue to construct this model here. So if I go back to SolidWorks here, and this is going to be your chance to ask some more questions. So if you have some more questions, this will be your chance to ask them. But here, what I can do is I can go new part in millimeters, front plane, begin a sketch, S key, line, single click, move my mouse over, 135, enter, move my mouse up, 12, enter, move my mouse back this way, 135 minus 25, enter, move my mouse up this way, 65 minus 12, enter, move my mouse over this way, and then I can bring it back down here to this lower corner, and now I can S key dimension, and I can dimension from, let's say, like from this plane, the right plane, to this line here, and then I can go to 15 degrees. Now that sketch is fully defined, but we're not matching the customer's design intent, so let's grab these grips here on these dimensions and move them over. Okay, now we're matching the customer design intent. Now S key extrude, right click mid plane, 85, enter, right? Because I know that that's the next thing that comes up. Now what I can do is I can go to this face here, begin a sketch, orient my view, S key. I'm going to create a construction line that goes from here to here. And then I'm going to do S key arc. I'm going to create an arc that goes from here to here. I'm going to say I want this arc to be tangent to this line here. So pick one, hold control, pick the other, make tangent. And then I'm going to do a dimension here, and that dimension is going to be 77 for the radius of that arc. And then what I'm going to do is S key extrude cut, right mouse button, through all both, and then immediately right mouse button again. And that lops off the front of that thing. Now I can pick this face here, begin a sketch, S key, line, single click, move my mouse this way, single click, come back, touch the endpoint, come off of that endpoint with an arc. Here we've got auto dimensioning in the arc. So that arc radius is going to be 26. Enter. Continue coming around till I'm at 180. Single click, move down to this point. Single click, move over to here. Single click, hit escape. Take this point and this arc, make those concentric. And look at that. Now that sketch is fully defined. Now S key extrude. And even if SolidWorks remembers that my last cut was through all, I could right mouse button here and say blind. And once you say blind, so even if it remembers, last time it was through all both, So if I right mouse button and say blind, then I can let go of my mouse and I can say that's supposed to go up to 9, enter, enter. And you can see how we're able just to kind of rip through this thing using these workflows to speed along this process. You know, we could go here to this geometry here, begin a sketch, orient our view, S key. This one, maybe I could do it with a slot tool. So I could come down here with a slot tool like so and create a slot. And then I could say, I want this radius to be radius 15. And then the depth of that line there, I want that depth to be 20. And then S key, extrude cut, right mouse button, through all, right mouse button to finish that off. And that gives me that through all cut there. And then to finish this off, we would just want to take advantage of either a whole wizard or take advantage of using, you know, there's some other shortcuts you could use here to kind of save some time. Like we could maybe use contour selection when you're doing a counter bore. You know, the correct way to do a counter bore is to do it with the whole wizard. But sometimes I'll see users do this: begin a sketch, S key, circle, wake up the center point, single click, move your mouse, counter bore larger diameter, single click, move your mouse, counter bore smaller diameter. And then what you could do is you can select the contour to include for the internal cut extrude. So we could do S key, extrude cut. And now this is going to go to a depth of 12, enter, enter. And then you can show that sketch or just pick on that sketch. And then you could do S key, extrude cut. And now this one, what we're going to do is we're going to go selected contours here. And we'll say that we just want to use this contour, then move your mouse. And then you can right mouse button through all, right mouse button. And that gives you a counter bore. Okay, it's better to do it with the whole wizard. That's the right way to do it. But it is kind of interesting to see how to do it with a shared sketch where you draw both circles at the same time. And there's certainly spots where that's, you know, like if this wasn't a flat surface here, if there was curvature on the top of this or on the bottom of it, it might actually be more beneficial to do it that way, to draw the two circles up on a plane or something like that to bring them down to the desired depth. But like I said, the right way to do this is pick a face, go into whole wizard, go through whole wizard and pick the correct size. So this one's going to be 5, 10, and 5. A lot of times in whole wizard, what I'll do is I'll say I want it to be a counter bore in metric. And then I just go down here to the show custom sizing. And then I just blast through this menu with the tab key on my keyboard. So I'll do like 5, tab, 10, tab, 5, tab, and then I'll go here to positions, and then I'll locate this thing using these points. In this case, I'll do a point here, and then I'll probably make this one just symmetric. So select, S key, center line, bring this up like so. This is going to be like so, and then I'll pick this one, hold control, pick this one, and then make those symmetric. Make symmetric so they move together. Okay, and then to locate this point here, what we could do is just add in a couple of quick dimensions. So the dimension to, actually, I think it's a center to center dimension, right? Yeah, so it'd be a dimension from here to here is going to be 10. And then the dimension from here to here is going to be the 55. And then the final feature on this thing is just those fillets, S key fillet. You know, what happens when you go into a standard fillet? The radius starts out as being highlighted. So as soon as you launch the fillet command, you can be confident that the radius is going to be highlighted. So S key fillet, type in the radius first, 20, enter, then pick your first edge. And then when you pick your final edge, it doesn't show up, but it's actually there, that thing with the mouse with the check mark up in the corner. That's what happens when you pick your final edge. Even though you don't see it, you can still pick that last edge and then immediately right click, and that finishes the command. So with the fillet workflow, it's like fillet, radius, enter, left click, and then left click, right click. And that's how you do your fillet workflow. You just start to remember that, like, the final fillet you add, you right click and that finishes it. The right click menu is so powerful in SolidWorks. So that's part 2. And then I have a couple of final tips here at the end, just a couple of little like bonus tips for sketching. But if anybody has any questions, please let us know what questions you might have. I'm happy to answer any questions you have. Javas says, if you have time, please instruct us how to use copy with mates in an assembly. It's a real headache. I wish you would give us some tips and tricks about it as well. Yeah, we can look at that. For sure. And let me know. I'll keep an eye on the chat if anybody has any other questions. if everything's good, Edward, are we on any kind of like a time constraint or anything? I think I got about like 15 minutes worth of material left, but I'm happy to cut it short if we need to.
No, it's fine. We are really enjoying this. You can
Okay.
use our 15 minutes.
All right, great, excellent. All right, so let me bring up extrude thin. You want to know more about extrude thin? Happy to talk about that as well. I'm looking for a sample file here. Go ahead.
It's so funny to see these workflows because I've seen even in the speed modeling challenges, all of them, they normally use these workflows like the arc command, the auto dimension and everything.
Yeah, Matab is like a wizard when it comes to some of these shortcuts.
Of course, yeah. And also Chris Barkin.
Yeah, really good.
Of course, yeah. Actually, I hosted the quiz last year, and he really recommended your channel, and also he shared a couple of the same tricks that you have shared, like set up the hotkeys and everything. Because he was
Nice.
also sharing, he was sharing his journey and everything, how he won that world championship speed modeling.
Oh, nice. Yeah, that was cool. That was really cool. So this is with regards to the request from Gervas. Said, if allowed, can you please show us how to do copy with mates in an assembly? So when it comes to copy with mates in an assembly, it's all about how you set it up. Like when it comes to setting up this hardware stack here, you have to be very intentional about how you set things up, because you can end up having too many mates, and then like you said, the copy with mates becomes a real headache. If we were to look at this in like a much simpler example, let's say we look at like this example here, you can see that what you can do is you can take this face and this face. So pick one, hold control, pick the other, let go of control, and you can mate those together. So that component now has a mate of concentric. And then we could take this face here, hold control. We could take this face here, mate those together. So that now has a mate of coincident. So you would say that this part here has two mates that are related to it. It's got one mate that's concentric and one mate that is coincident. So now if we were to right click on this part and we were to say copy with mates, then what we can see here is that we can take that one part and we can make a copy. And SolidWorks realizes that there's two mates, and that those two mates go from this part to this part, and that's it. That's the only way to to get back to it. So that's the only way to that's the only two mates that are related between this part and the rest of the assembly. So if we said we wanted to make a copy of this part, we could say we want to copy it and we want the new copy to be here, and we want the new coincident to be here. And so what that does is it makes a full copy of the entire stack. It makes a copy of this bolt into the new location, but it also makes a copy of those mates. So this mate here is copied and this mate here is copied. And that's really helpful when you've got like another instance of this part that maybe is at a weird angle. So if I take this part and put it over here and I'll fix this part at this weird angle, well, now what I could do is I could right click on this part and I can say copy with mates. And then I can say that I want to relocate it so that it's concentric over here, and I want to relocate it so that it's coincident over here. And that's really helpful. I could repeat that. So I did a right click there to advance concentric, coincident, repeat that, can go over here. It could be concentric, coincident, et cetera, et cetera. But the thing is, when you do a copy with mates, what SolidWorks does is it looks at all of the mates that are in the entire stack, and then it determines which one of those mates are related back to the assembly. So what I'm going to do here is I'm going to make a copy of this part. I'm going to make a copy of this part. I'm going to make a copy of this part. And I'm going to make a copy of this part. I'm holding control and dragging those parts. And then what I'm going to do is I'm going to say that there's a mate that goes between this part and this part. I'm going to make that concentric. And there's a mate that goes between this part and this part. I'm going to make that coincident. Oh, actually, you know what? Sorry. Let me undo that. I'm going to make a mate between this part, and I'm going to make that concentric. And then I'm going to make a mate that goes between this part here and this part, and I'm going to make that coincident. And then I'm going to make a mate between this part, and those are going to be coincident. Now, what have I done there? What I've done is I've created mates between this part and the assembly, and I've created mates between this part and the assembly. So what will happen now is if I right click and I say copy with mates, and I say I want to copy this part and this part, well, I end up with a long line of mates here: concentric, and coincident. Okay, so it's concentric. The washer is concentric to the assembly, the screw is concentric to the assembly, and the washer is coincident to the assembly. But what about the other mate? What about the mate that's coincident between these two parts? Well, because both of those parts are being copied, they don't end up getting you don't end up getting asked to define what's going on with that mate. The copy will automatically pick up on the mate between those two components. So when I go to make a copy of this thing, let's say I want to make it down here, I want it to be concentric here, and I want it to be concentric here, and I want it to be coincident here. Well, the coincident mate between these two components was included in the stack, so I didn't have to define that coincident mate between those two components. Now, that's really, really important to understand, because what that means is the less mates you have back to the main assembly, the better. And the more mates you have that are in the stack, the better. So what I mean by that is if I get rid of, I'm going to get rid of these. So delete that one. And now instead what I'm going to do is I'm going to say that I want to take this component here, and I'm going to make another mate between that component and this component here. I'm going to make that concentric. Okay, we'll move that off to the end here, and we'll take this component here, hold control, and this, and we'll make that concentric. So now that's two more mates to the assembly, and then I'll take this face here and this face here, and I'll make them coincident. So that's three more mates to the assembly, and then I'll take this face here, and I'll take this face here, and I'll say that I want those to be coincident as well. Now that's not to the assembly, that's to the stack. But now if I go to this component and I say copy with mates, and then I say that I want to grab the entire stack, so I'm going to grab this, and this, and now I go next. Look at this list of mates that we have now. And we're going to have to go through and pick all of those things every time. You got to pick coincident, concentric, for all of them, because we created the mates to the individual, from the individual component back to the main assembly. So that becomes a real headache when you try to do copy with mates. But if we were smart about it, the way that we created these mates, so if instead of making the mates all back to the main assembly, if instead we just had three mates, so the screw is concentric to the hole, the washer is coincident to this face here, and the washer is coincident to this face here. And then everything else is concentric to the screw. And everything else is coincident to the other components. It's coincident there, it's coincident there. Then we get a very elegant copy with mates. So if I go to this component here now and I say copy with mates, now I can go through and I can pick the entire stack. But when I go to the next screen, I'm only presented with three individual choices, and they are the most logical choices. So what do you want the new stack to be concentric to? I want it to be concentric here, I want it to be coincident to this face, and I want it to be coincident to this face. Now I can right click to make another copy. Right click. What do you want the next copy to be? I want it to be concentric here. I want it to be coincident to this face, and I want it to be coincident to this face. Now you can right click to make another copy. And what do you want the last one to be? I want it to be concentric here. I want it to be coincident to this face, and I want it to be coincident to this face. And so that is how you can get very elegant with your copy with mates. You can just be very intentional about how you define the stack and try to make the mates internal to the stack. So if it doesn't have to be concentric to this part, the assembly part, if instead it can be concentric to this part, the part that's in the stack, do that. If it doesn't have to be coincident to the assembly, if it can be coincident to something in the stack, do that. And you're going to create a situation where you can use copy with mates and get really, really fast results and get a really nice, in this case, a nice assembly stack here. And what's cool is that each of these is an independent copy with independent mates. Now, sometimes that's not good. Sometimes it's better to do a pattern for performance. But in this case, you wouldn't really be able to do a pattern. You know, they're all at different angles. They're all at different widths, holding these things open. So, you know, you wouldn't really be able to do it with a pattern. You'd have to do it with copy with mates. So that is the answer to that question. Do a little bit of copy with mates. Yep. When Yama said, is it possible to switch from thin to not thin? No, I don't think it's possible. It's been like a long-standing limitation to SolidWorks. I don't think they've changed it in the newer builds. This is a slightly older build, just because I like the older builds better. They're faster, they're more responsive, they're less buggy, they don't crash as much. So I like the older builds better. But you can see here that once you kind of commit to something being a thin feature, you can't really go back and make it solid. There's not really an option to do that. So all you can do is like manually manipulate the geometry downstream. Like if this is something that's now very far downstream, you could do something like insert face delete and maybe get rid of these internal faces here, and that would turn it into a solid. And then you could make a new sketch to define non-uniform wall thicknesses. I've certainly had to do stuff like this. I don't like it, but I've had to do stuff like this. Yeah, I don't think there's a way to change it. Once you make something a thin feature, it's like you're locked out of unchecking that option. Is there a way to get back without deleting or repeating extrude? Yeah, no, that's all you can. That's if you have like 50 features downstream, or even 20, or even 10 features downstream from this, then I would use this workflow. I would like downstream, I would do delete face and then patch it up that way. If there's like only 1 or 2 features, I would probably just delete it and recreate it. Yep. Are the majority of these tips and tricks on your YouTube channel? Yes, a lot of them are on the YouTube channel. We have a playlist called Power Moves where a lot of these are listed. That's awesome. Big thanks. Yep, my pleasure. You're welcome. Okay. In my SolidWorks, the mates related to toolbox get created automatically just by making the nut close to the screw, for example. Yeah, that's called those are called mate references. So if you examine a part like this that comes from toolbox, there's a feature in the tree here called a mate reference. And what a mate reference is it's a way of like pre-cooking this edge to look for a hole that has a cylinder and a planar face. So if I was to create a new part here, and then I create just a revolve, just a simple revolve here like so. And this. And then what I can do is I can click on an edge of this revolve. So I'll click on this edge here, for example, and then I can go insert reference geometry mate reference. And what I'm doing here, and this is all you have to do, you just do that and then you hit the green check mark. What I'm doing is I'm telling SolidWorks that if I drag this part in and this edge gets close to a hole, and that hole has a planar face and a cylindrical face, so let's say this is the opening of the hole here. So it's got a planar face and a cylindrical face, add 2 mates to that part. So I'll save this one, and we'll call this sample mate reference. And then we'll go here to here. We'll go back here to the assembly that I created earlier. And then I'm going to press tab here. This is how you hide components. Use tab to hide components. And then I'll go insert component and I'll grab that part. So here's the sample mate reference. And see, as soon as I move it near one of the edges of this hole, it will create the mate to that hole. So it's actually creating 2 mates there. It's creating a concentric and a coincident to that edge. So if you look at the tree here, you can see there's a concentric mate and then there's a coincident mate that are created there between those two. Concentric, coincident. Because the edge that I picked is at the intersection of a cylinder and a plane. So this is a plane here. This is a cylinder here. So that edge that I picked is related to that. So all the toolbox parts have that cooked in. They're called mate references. Can you teach us a better way to copy and paste one sketch to another new part with all the relationships and move around with the relationships of one part? Yes, absolutely. Be happy to do that. Yes, exactly. So I think that's easier than making mates by yourself and copying them. Yeah, you can do it that way too, but it's not the same as copy with mates. That's like a different discipline. That's like your copy with mates is used for a stack of components. Mate reference is just used for one part, and it only works if the edges aren't filleted or chamfered. If they're filleted or chamfered, then you don't have a cylinder and a plane coming together at an edge. Some exceptions for like a conical face. There's some exceptions, but yeah, for the most part, yep. All right, so to finish things off here, we'll just talk about a couple of highlights from the world of SolidWorks. First of all, trim. When you're in the trim command, the power trim is such a powerful command that people often forget about. And then there's some like little bonus functionality in the power trim command. So when you're in the trim command, you can power trim. I think a lot of people know kind of like the basics of how it works. When you're in the power trim command, you can you click trim. Over here, you've got the very first option, which is power trim. You left mouse button and drag, and then anything you drag through gets trimmed. Something that a lot of people don't know is you can actually backtrack. So if you go back over this little square here, you can back up a little bit if you trimmed the wrong thing. So like if I was trying to trim through here and then I accidentally trimmed that last line, I can hit escape and then Control Z and go all the way back to the beginning. Or when I'm in the trim command, if I trim through and get this last line by accident, I can just backtrack over it and then, get the one that I meant to get. So that's a nice time saver if you know about it. And then trim can also be used to extend the lines. So normally when you need to extend a line, you could just grab the endpoint and move it over like this. Like that's how you would extend the line. But if that endpoint has a coincident relationship, then you're kind of stuck with it. If you get into power trim here, probably trim these off like this. Let's say I'll trim all this off like this. What you can do, actually that had the coincident relationship. What you can do with the trim command is you can grab this line here and you can extend it to this line over here as well. So you can kind of break that relationship using the trim command. So it's got coincident there. You can left click and drag and break that relationship with the trim command, which is often helpful. One of my favorite things about the trim command is convert trim geometry to construction. This is really helpful when you trim and the trimmed result ends up losing dimensions. So this happens a lot with like circles. I've noticed if you have a circle and the circle has a dimension on it, and then you trim that circle, a lot of times you'll end up losing the dimension. So you go trim and like the dimension will go away. Well, one way that you can work around that will be you can do keep trimmed entities as construction. So you check that on, and then when you trim through, whatever you trim through stays. It just ends up changing to being for construction. So that's really helpful when you're trimming and you lose that that geometry. That one can be super, super helpful. Kind of speed running these, I know. Convert entities, I will talk about that a little bit later. Let's talk about intersection curve because this kind of gets into the question that you had. So when you're using intersection curve, what you're able to do is you're able to recreate the geometry from an imported part. So here's what this could look like. Let's say I've got this flange that I imported, and now I want to recreate that geometry. So we'll go in here to SolidWorks, and we'll go to, let me go to this lesson. Stand by just a moment. Couldn't find the folder. I got it. We're back on track. So we go here to this and this, and we're going to reuse sketch. This one, right? Nope, not that one. Where's my flange? Oh, intersection curve. That's what it's called. Intersection curve. So we're going to, we've got this part here. Now, let's say this part is like an imported solid instead. So instead of it having a feature tree, let's say it comes in as an imported model here. So you see it says imported, like this is a step file that we just brought in as an imported solid. Well, what we can do is we can launch the command intersection curve. Now, what the intersection curve command does is it lets you go to the front plane, begin a sketch, and then go in here to intersection curve, and then it lets you select faces from the model and convert those faces into sketch geometry where they happen to be intersecting with the current model. So this is a little bit different from like convert silhouette edge, because when you use the intersection curve command, you can see that what happens is it's just figuring out where the intersection is with that plane. With the silhouette edge, it's more so with like the projected location when you're looking at it. So this can be really useful when you're trying to do things like define a gasket that's going to run through this part. Like look at this part here. It's got this kind of drafted face here going down this side over here. So if we were to go to, let's say, the right plane and begin a sketch here on the right plane, what we can do is we can get an intersection where the geometry is running through here so that we could define the geometry of that gasket. So I could say, like, I want to take this face, this face, this face, all the faces all the way around, hit the check mark, and then what I'm doing is I'm gathering the intersection. Even if they're drafted faces or at like an oddball location, like if I was to take this face here and hold control and drag it a little bit so that I'm in this location up here on the front, now I could go onto that face and I could choose intersection curve and then choose these faces here. Well, this one doesn't intersect, but these faces here, and hit the check mark. And wherever those faces are intersecting with the sketch plane, now that could become like the path for my gasket, or, you know, something similar to that nature. So in this case, what I'm doing is I'm taking this shape here and I'm grabbing all the geometry from this shape and turning it into sketch geometry. So now what I could do is I could maybe take a line here, like a vertical construction line, make a vertical construction line there. Or actually, maybe the first thing I'll do, let me get rid of that. Maybe the first thing I'll do is I'll go in here to the sketch, and then in the sketch here, what I can do is I can say delete, display delete relations. And then here, what I can do is I can say delete all. So now what I've got is I've got a sketch here that doesn't have any sketch relationships. So I don't want anything to be related back to the original shape. I want to create my own so I can revolve this thing into its own shape. So now what I can do is maybe create a sketch line here, a vertical sketch line. Let's make that vertical like so. Let's get into a front view here. I can get rid of this geometry here. Maybe I'll hide the solid body just to make this a little easier to see what we're doing. And then I could right click in the background. And when I right click in the background, I can choose fully defined sketch. So from fully defined sketch here, what I can do is I can say that I want to add dimensions and relationships to this sketch. So I'm going to add dimensions, and I'm also going to add relationships to the sketch. You saw a moment ago, there's nothing on the sketch. There's no vertical, no horizontal, nothing like that. The cool thing is that with the fully defined sketch command, you can click on a center line and then define that as the origin datum for your dimensions. And then what you end up with is this. So it actually goes through and creates driving dimensions here. And these driving dimensions, you can see, are actually centerline construction geometries that you might want to use when you're actually turning this thing into a flange. So that's how you can take intersection curve and use it to kind of reverse engineer a part. Now, one of the questions that came in the chat was, can you help us with moving sketch geometry and copying and pasting sketch geometry? So in this case, you can see here that this part was originally in inches, and now it's in millimeters. And I want it to be metric. I want my version to be metric. So what I could do is I could take this whole thing, Windows select everything, Control C, which is copy, hold Control and press the letter C. That's your copy shortcut, Control C. And then I can make a new part here, and I'll make this in my millimeter template. I'm going to go front plane, begin a sketch, and then I'm going to click here in the background. I'm going to press Control V. So that pastes the sketch, and it pastes all of the relationships except for the external one. So you notice, like, I didn't get the height dimensions. They didn't come with. That's because those dimensions were external. But, you know, we can add them back in. But then the challenge is, how do you get this geometry to move onto the origin? Like when I try to grab this geometry, I try to move it here onto the origin. It doesn't want to move. Now, there are some move tools in the sketching tools up here, but the one that I use the most, that I find to be like the most valuable, is you window select all this geometry and then you hold Control. Now, what happens if you hold the Control key on your keyboard and you go to drag this? You get a copy, right? I hold Control, I drag over here, I let go, and now I get a copy of that sketch. Well, that's not what I want. Okay, well, what if I grab this geometry and then I hold Shift? I grab this point and I hold Shift. Well, that lets me move it, but it doesn't let me create a relationship to the origin. I want to drop this right on the origin, but I can't because, like, it doesn't let me create that relationship. I have to zoom way in. I'm sure some of you have done this before where you zoom way in and just try to get it really close to that point. So what we can do instead is we can combine those two ideas. You can window select everything. You can hold control, begin dragging. And this is really cool. You'll notice it's got the little plus there, and you notice on my keyboard, I'm still holding control. Well, then what you can do is you can let go of control, and look at that. The copy icon went away, but you can drop this directly on the origin, let it go, and it picks up the relationship to the origin. How cool is that? So that is like the super secret shortcut that you can use. Use the intersection curve to kind of back engineer something or bring something into your own design. Now we can go through our own design here, and now we can change this and make it proper metric. But that whole hold control and then drag to copy, I learned that from like a true SolidWorks wizard, and it's a really cool function that you can use to hold control and drag, and then let go of control to stop copying, but to still be able to pick up on that relationship. We're kind of running out of time here. So the final thing I just want to say to you about this intersection curve that I use a lot is when you have geometry that you need to compare to an earlier version of the design or a different version of the design, this is another spot where I use intersection curve quite a bit. So what this looks like here is if we take this part here and we bring it in. So this part here you can see was created with a loft. The loft goes from 99 millimeters down to 77 millimeters. And the customer says, I don't really like that. I want to change it a little bit, but I kind of want to see a before and after. I want to know what it looked like before, and I want to know what it looked like after. So what you could do here is you could go front plane, begin a sketch, and then you could go here to intersection curve, and you could pick this geometry from the part. So I'll pick these faces here that are kind of running around the outside of the part, and I'll hit the green check mark, and that gives me that intersection curve. Now I'm going to start making changes. So what do I want to do? I want to take this sketch and I want to drag it up to the top of the tree so that the changes don't affect that sketch. Well, I can't do that if I've got these dynamic relationships here, these intersection curve relationships. So what I can do is I can go here to display delete relations, delete all, hit the green check mark. Now there's no relationships there. So now I can exit that sketch. And now I can take that sketch and I can drag it up to the top of the tree because it doesn't have any relationships anymore. It's just like a dumb sketch. Now I could right click on that sketch and say sketch color and make it like a red color or something that really pops out. And now I can work with the customer and I can say, well, what if we change this bottom dimension to 75? Let's see how that looks. And what makes this so effective is that we can go to a front view and we can show the customer how this is kind of pulling in a little bit here. This is what it originally looked like, and this is what it looks like now. Then the customer might say, let's make it a little bit smaller on the bottom. Let's make it 73, and let's make it a little smaller on the top too. Let's make it 97. And now again, we can go back to that front view and kind of show the customer, how about that? Does that look better? And then the customer could say, yeah, that looks much better. So that's just another spot that I've used intersection curve a lot on, is just kind of like in the real world, trying to do a comparison to an earlier version of a design. It's not really what it was intended for, but it's something that I've used it for a lot, like especially in 3D printing when you're making little subtle changes and you want to kind of see what the difference is. All right, guys, we went for a while there. I hope that you feel like you got a lot out of that one too. Edward, I think that's probably where we're going to have to stop just because I'm going to be live streaming today. We have the tournament today. But of course, I want to say thank you so much for having me. And I'll see if there's any other questions I could answer. But this has been a lot of fun.
Yes, Toby, thank you so much. I really learned a lot, especially on the last about that changing of dimension, and also you have like a reference sketch that you can say, oh, this is how far the model has changed. I mean, that's really impressive. And also, I'm so curious about the intersection curve. Does it work if you are dealing with a scanned part? Let's say you import like a scanned document, which is just a bunch of meshes, and then you wanna reverse engineering from that. Would intersection curve also work?
I think there's a tool in the scan to 3D tools that does something similar. This tool won't work with a mesh. You have to have an actual like B-rep face, so it'll work with a surface and it'll work with a solid. But I think in the scan to 3D tools, in these tools here, when you bring in a mesh, I think there will be a similar tool that lets you do an intersection curve. I guess what I'm saying is I don't think it's accessed the same way. I don't think you get to the tool from Sketch. I think you get to it when you're importing the mesh and you're using like it's got the like mesh refinement wizard, those tools. I think the tool is in there, but it does do the same thing. It does let you drop in a plane and then it grabs a sketch going in that area where the mesh is. I haven't done scan to 3D in a while, so I'd have to go back through and look, but I would look for it. There's a tool that does something very similar, yes. I just think it's a different tool, but it does the same thing, very similar.
Okay, okay. I think I will also dig a little bit deeper on that.
Yeah, yeah. When you're bringing in a scan, I could see that being very, very helpful. Okay, awesome. Thank you all so much for the kind words. Very nice to see everybody in the class. Hopefully you learned at least 3 new time-saving tips and tricks. Hopefully you got some of your questions answered. Hopefully you had some fun, right? It's supposed to be fun. Don't forget, if you're ever interested in getting certified or taking any training classes, you can visit us, tootalltoby.com/training. And if you have any questions on that, you can reach out. Let me know if you do have any questions about that. And don't forget to visit us. TooTallToby.com is the gamification of 3D CAD. And then, of course, we've also got CADpractice.com. Don't forget about CADpractice.com. I know there's some users in the Tanzania users group who are crushing it on the leaderboard. So if anybody...
Of course. Yeah, I would like to give a shout out to Mohammed Boki and the Abiudi Elias. These are actually students here at University of Dar es Salaam. They are mechanical engineering students, and they are so eager to learn 3D CAD. Can you unmute your mic, say something to Toby, because they are so excited to have a session with you. Abiudi and Mohammed, if you can hear us. Mohammed Boki and Abiudi Elias. Oh, I think they're like, yeah, but yeah, they are so excited, and I think they will be on the top of the leaderboard, #1.
Yeah, I think they're gonna get there for sure. Yeah, nobody's got. There's one achievement that no one has gotten yet, which is the CAD Skills Master. So as you're going through and doing these challenges, the challenge is to get 100 points in all 12 categories, and nobody's gotten it yet. So maybe one of them will be the first to get the CAD Skills Master. We've got some people who got 50 or more in all 12, but we haven't had anybody get it in 100 in all 12. So we'll see who is the first person. Maybe it'll be somebody from the Tanzania group. That would be pretty cool. We'll have to have a special recognition if that happens.
Oh yeah, that would be so awesome.
Yeah. So guys, stay in touch. I'm on social media. I'm on a lot of different platforms. So stay in touch. It was nice to see everybody in here today. A lot of fun. And let us know, as always, let me know if you have any questions or if you want to learn more about cadpractice.com or Too Tall Toby or the training or anything like that. But yeah, again, I just want to say thank you so much. This has been awesome. Shout out to Edward.
Thank you.
Yeah, Edward, shout out to you. Thank you for organizing and keeping the user groups going. I've been part of user groups for a very, very long time. So it's awesome to see them. And they only work with people like you. So thank you.
Yeah, thank you so much also for agreeing to present to us. I know with timing and everything, you are supposed to present for like 45 minutes, but you were able to manage to reschedule the time to an area time zone so that we can all have fun and have more room to wiggle around like this. So
yeah, that was great. No, thank you. Yeah. So we're doing the CAD versus CAD tournament, the World Championship of 3D CAD speed modeling. So today we're going to have people qualify to enter the tournament. And then next week, we're going to have people qualify. And then the week after that, we're going to have people qualify as well. So that's what I'm doing next. I'm going to go live stream on Too Tall Toby on YouTube. And then people are going to be trying to model. So if anybody wants to practice, I'm going to have some more of these challenges posted on that live stream. And you can certainly continue to practice your CAD skills. But I'm sure we're going to see some super fast modelers in that speed modeling qualifier.
Oh yeah, sure. Excited for that. Excited for that.
Yeah, it's gonna
And
be cool.
also, yeah, I was planning to have a 25 gift card for the winner. I don't know how we're gonna do this
Oh yeah,
because I,
yeah. Sorry, sorry, I let you down with the quiz.
oh yeah. But do you have anything in mind on that?
uh, we could. I don't know. I could maybe send you. I don't know. Do you have the Kahoot? I could probably spin something up quick in Kahoot. Maybe I could send you something on LinkedIn, and we could have people like try to take a quiz or something through that.
Oh yeah, sure. I
I'm not
think that
sure.
would be fun.
Okay.
Oh, we can.
Let me see here. How many questions do you think we should do for the quiz?
I think not more than 10. If six,
10.
8,
Okay.
not more than 10. Yeah, I think that would be
Okay.
fun.
All right. Let's see if we can get something spun up here real quick. All right. There's one. Maybe we'll just do like 3. we could let's see here. Okay. There's 2. We're cruising here. We're like speed running the quiz. I love it. All right, let's see if we can come up with one more.
Oh yeah, I see the question that you sent me on LinkedIn here.
Yeah, I'm sending them to you on LinkedIn.
Okay,
I don't have access to Kahoot.
okay, no problem. So I think I should leave them and then maybe they can answer in the chats. Oh,
Oh, I like that. Yeah, you can do it that way. Yeah. That's pretty good. Yeah, I like that.
okay. So yeah, question one is what is Toby's favorite shortcut key? Can you type anything in the chats?
Man, they're
T.
fast. They're really fast.
So are they correct, Toby?
Yeah, they sure are correct. S key is the number one shortcut key for me.
Okay.
Yeah, looks like it was MEJDA. They got it first, right?
Okay, okay. So we are moving to the next question. How can you access the menu of end condition when doing an extrude command? How can you access a menu of end conditions when doing an extrude command? Oh, we have Dixon, right click, right click. Whoa, whoa,
They're
whoa,
so
whoa.
fast.
Oh, they even remember the RMB. That was right
Yeah,
mouse, but
yeah.
it's
Right
so
mouse
cool.
button.
Right mouse
Yeah, right
button.
mouse button. Yep.
Okay, moving moving to the next question. What tool can be used to turn a collection of sketch entities into a one single group? Block,
Wow.
block, block from
Yeah, they're
Gelvers.
so fast.
Okay.
Well, I don't know how you're
Uh,
gonna solve it, man. I'm sorry. I should have had more. I just didn't have time to do the quiz this morning.
yeah, no problem, no problem.
Yeah.
So yeah, last question. Sheet metal, edit sketch, color block, intersection curve.
Oh, that was
Oh,
just
this like,
those were the answers.
oh, okay, okay.
Yeah, like I wasn't sure if you were gonna do it in Kahoot. I wanted to give you some different answers you could drop in there.
Yeah, okay. I don't know how I'm gonna select the winner now.
I know. You gotta do like a random, like just put everybody's name on a wheel or something and do it random.
Yeah, can we do that? Can you do that,
Uh,
Toby?
I don't know if I can grab the full list of names. Hold on, let me see if there's a participant thing here. Let me see what happens if I try to put this in Notepad. See how it comes out. Yeah, we can do it, I think. It might take a couple of spins, but I think we can do it.
Yeah, I
Let me
think
try
that
it.
will be so cool. It will be pretty cool.
Yeah, we can do it, I think.
And of course, yeah,
Okay.
don't hesitate to even present in your upcoming events. I mean, as you can see, the energy is it's so high. People they are eager to learn from you.
Yeah, I was gonna say maybe we could end up doing this again sometime.
Yeah, sure. I'm really looking forward to that.
Yeah, it'd be cool. All right, let me share my screen here. So what I did was I just grabbed the whole list of people from the attendee list, and I just dropped all their names in. So it says like their name and then it says presenter. So if it comes up with one of those, if it says like presenter, or if it says like if it says presenter, then we're not going to use it has to be somebody's actual name. Wait, I don't know if this got everybody. Hold on, it looks like it's a little bit short. Let me try again. Did it get? Hold on, I think the list is short. Let me try again. Is this getting everybody? Oh, there we go. Okay. That's better, right? So if it has your initials or if it has your name, you win. But if it lands on this one here, presenter, then we're just going to spin it again. Okay, does that sound good to you, Edward?
Yeah, that sounds pretty good.
Yeah. All right, here we go. Let me shuffle this. Shuffle, 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 shuffle. Oh, and what's the prize?
Actually, it's a 25 gift card.
Whoa,
$25
nice.
gift card. Yeah.
All right, good luck, everybody. All right, here we go. And spin. All right, let's see what happens.
So excited. What if it landed on
Yeah,
my name? Are we gonna
yeah,
spin
this
it
is
again?
exciting. Okay, there you go.
Oh, Ahmed Abdelmonem. Oh, congrats, Ahmed.
Yeah,
Please, yeah,
congratulations.
share your
So,
details. Can you please, Ahmed, share your details with me in my email? I'm gonna type it in the chat right now, and I think we can, yeah, we can work out on this.
Awesome. Cool, man. That was pretty fun.
Yeah, that was pretty fun.
I like it. I like it.
Okay.